Let me see if I can, if we can work through this. This is a positive, this is a negative plate. Does it make sense that this is going to actually accelerate as it goes towards the plate? Okay.
And we saw it in the hockey.
What's that?
We saw it in the hockey. In the hockey was positive.
Oh, yeah, we saw it in the hockey. We know the charge, and this is what I was getting all caught up about. Since we know the charge, we know this is all true. And do we remember this equation? E is F over Q. Do we know E?
Oh.
Yes.
Yeah.
Do we know Q? Now we do, after a careful rereading of the problem. So what that tells me is the work done is simply going to be, so that means F is EQ. It's just going to be EQD. So the change in potential energy is going to be negative that. It's going to lose potential energy, right? Because it's like, it's being attracted towards the plate. So it's like falling down to the plate. So like if I drop my pen, it loses potential energy. So we're losing potential energy as we go towards the plate. So calculate that out, yeah.
I do not, it just...
All right, so once again, hopefully that discussion isn't freaking you out too much. Just look at the basic, what the problem is saying. There is this particle with this charge in this electric field. F is EQ. That's the amount of force that this field is going to exert on this particle over this distance. That force exerted over that distance is the change in potential energy. Okay, so the potential energy, you're going to lose this potential energy, and then that potential energy is going to become the increase in kinetic. Just like if I drop my pen increases in kinetic energy, and that kinetic energy equals the potential that I started with. So, if I want to know the final velocity, then I say the kinetic energy final is going to equal the kinetic energy initial plus the change in potential. So this is 1/2 mv final squared. That's 1/2 mv squared, mv0 squared plus EQD. And so, I don't know, whatever, we can do the algebra there. But this is going to be the square root of all that divided by m over 2. Okay, no responses, so we'll do it. It was EQD. Was E 400?
Yeah.
400 times 1.6 times 10 to the minus 19 times 7.5 times 10 to the minus 4. And that's 4.8 times 10 to the minus 20. So did you get 4.8 times 10 to the minus 20 joules?
Yeah.
Okay, so then I can now plug that all into here. And when I do that, basically, let's see, that's going to cancel that 2 from that and that m. So it's going to be V0. So I'm going to get, V final is equal to the square root of V0 squared plus EQD over 2EQD over m, I believe. Double check my algebra, but, right? If I divide EQD by m over 2, I'll get 2EQD over m. If I divide this by m over 2, the m's will cancel, and the 2 cancels the 1/2. So from this, I will then say, if I take the square root of v, which is 800 squared, is that minus or plus?
What is that?
It's plus, okay? Plus 2 times 400, which was E, times 1.6 times 10 to the minus 19. That's Q times D, which is 7.5 times 10 to the minus 4. Oh, crap. Minus 4 EQD over M. And M was given. What was M?
2.0
Sorry?
times 10 to the negative 25.
2 times 10 to the minus 25. And do you get like 1,058 meters per second? So I get an answer of 1,058 meters per second.
It's like Mach 4, right? Mach 3? No.
Yeah, almost Mach 3.
I'm gonna get it next time with the scram chair. Mach 15. That's so fast.
Okay, did you get that answer? Did I make a mistake? It's possible. Yes, no? Please make sure you get that answer. Get it? Please calculate it now so you can see if you got it. Good? All right. Good. Okay. Oh, it just started recording.